Hi everyone, good afternoon. This is a group from University of Tennessee, Knoxville. Now we are going to present our project that is Rural IT Solutions for I-40 at Rockwood Mountain and I-75 at Jellicoe Mountain in Tennessee. I am Yang Song. The rest members are Harry, Jane, Zhen, Nima, and Ava. So now let's go back to the rural locales to see what's the problem of those two areas are facing. Due to the bad weather, worse grid conditions, frequent rockslides, and traffic jams on the mountainous interstate, those two areas are experiencing high crash rates. As you can see, the pie chart from weather report reveals that I-40 mainly suffers from hazards on the road, which could potentially be the rockslides, while I-75 and Jellicoe Mountain areas mainly suffers from the bad weather like fog. All of those factors pose a great threat to drivers' lives and properties. Now, just as the National Highway Traffic Safety Administration published, more fatalities occur per mile driven on rural roads than urban roads. In addition, the statistics indicate that the fatalities in rural area of Tennessee are always greater than urban area, and at the same time, it is showing an upward trend. So, why rural roads are so deadly? Conclusively speaking, it is because of the poor road layouts and design, frequent rock slides, and weather hazards and so on, which are totally different from our urban areas. Now, since we have found the key problems and we cannot do that by ourselves, so who will join us? In our proposed solutions, we act as a road safety cloud guardian. The surroundings are first the data providers. Data from different sources could give us insights into the timely and historic traffic states, and that's the foundation of our solutions. Then the partners, who are our research institutes and emergency management agencies, will analyze the data to put forward the solutions or do some quick responses when they receive the real-time data. After we mine out the data, we will let our users know what happened in ahead of them. And finally, according to the feedbacks from our partners and users, our TDOT will do further operations and maintenance. Now, let's welcome Harry.
Thank you, Yang-Song. This is Harry, and I am going to describe the proposed remedies of this project. I will first introduce the data we used in this proposal. Here, two major types of data are listed on the left. One is the real-time data. It contains the Waze user report and the real-time travel information from Google APIs. The other type is historically archived data, including the historical Waze reports, traffic condition from NPM-RDS, and the incident reports from LocateIM. Based on the historical data, we can design two functionalities. First is the historical data mining to find the hotspot area and the vulnerable segments. Based on these results, we can take some special engineering measures to improve the traffic safety of our rural communities. To fulfill this functionality, we need to build a cloud library as our data operation center. The third functionality we design is dynamic predictive operations, which provides AI-based crash risk prediction and hierarchical crash alerts. With the support of the real-time and historical data, we can design and deploy a road brain system, as shown in the next slide. In this slide, I will describe our design framework of the road brain system. As we can see, the inputs are different data sources such as travel time, Waze reports, the traffic volume, weather condition, and the grade level, and so on. The road brain in the middle is the core processing system based on AI techniques and statistical methods. The output is mainly divided into two parts. One is historical analysis results, such as the crash rate, the crash severity, the hotspot areas, and the course distribution. The other part is the real-time risk level prediction, which provides the estimated probability of risk occurrence, as shown in the above picture. This graph mainly illustrates the high-level architecture of our proposed system. Generally speaking, we have three main parts: the server, front-end, and back-end. The first part is to establish our server, that is to design and build a cloud library based on different data sources. Then the cloud library will contribute to building the backend, that is our central processing unit, the road brain system. With the server and backend prepared, some front-end results can be easily presented in different ways. For example, the historical analysis provides the information about the traffic safety on targeted corridors, and these results support the decision-making process of implementing some engineering work which is suitable for our rural communities, such as the pavement maintenance, the geometric redesign, and so on. From the perspective of real-time operation, the hierarchical risk alerts can be displayed on the message sign and updated in a real-time manner, which can provide timely and necessary traffic information for vehicle drivers.
Thank you, Harry. Hi there, I'm going to briefly introduce the cost breakdown and timeline data provided in this figure. There are several different types of our costs. The personnel costs mainly come from travel fees and office work facilities. Besides, the project budget also includes initialization, installation, maintenance, and construction. For example, we will investigate labor and resources to build and maintain the ongoing cloud library. For the constructions which cost the most, we need to set up warning signs and consolidate mountains to enhance the safety levels. We arrange our work within 36 weeks. The first month is to build the data center. Another month is to compute the modeling using AI. After that, we need about 20 weeks to redesign the roads with higher safety levels. Finally, we evaluate and report the performances of our solutions and make a before-after analysis.
Thank you, Jen. Based on the predicted probability of crash rate, we conclude some anticipating impacts of this research from different aspects and from different stakeholders' perspectives. For the TDOT, they can improve operation by obtaining crash information in advance and prepare for the risk of crashes, and then take corresponding measures to prevent crashes. Therefore, the cost of repairing road damage caused by crashes will also be reduced. For the road users, the predicted crash risk can be helpful for reference for them to take corresponding driving operation. Safe driving behaviors can improve road safety, and the travel time delays caused by crashes can be reduced. From the perspective of partners, like emergency management agencies, and as the road crashes rate decreased, the expenses for accident management and medical assistance will also be reduced. And that's all of this research. Thank you for your patience. We would love to hear questions and comments from you.